Okay. Hi guys. Sorry that I wasn't able to do the virtual Zoom session. I hope this video is still helpful to you. If it's not, and if you have further questions, you can always send me an email. But let's get started. I'm going to try to get through everything quickly but thoroughly at the same time, because I don't want to take up too much of your time here. But I also want to give you sort of as much of the rundown of the work as I can. So we will start with number one. So Dustin walks from his house to a bus stop that's 300 yards away. So we'll say that if we're starting at Dustin's house, we're starting at 0. So we'll say the house is our origin. Okay. And then we'll say somewhere, some point along here is the bus stop, which is 300 yards away. Right? This is bus stop B. This is house. Okay. And then I'm saying when Dustin's distance from his house increases from 100 yards to 200 yards, so when Dustin is 100 yards here, and let's just say this is 200 yards, I want to know this distance, and I want to know this distance, and I want to know how they vary. So what we could do, right, is just take the distance value here, subtract it from the distance value here, and that'll tell us the distance between the 2 points, right? So if that's the case, distance 1 is defined as 300 minus 200, sorry. 300 minus 200 is 100. And then distance 2, we can say is 300 minus 100, which is equal to 200. Let's not put this as defined. Let's just leave it as D1. So that means that when he is 100 yards from his house, so when he's here, he is 200 yards away from the bus stop. And when he's 200 yards from his house, he's 100 yards away from the bus stop. Right? Nice. Number 2, popular sports drink can be made by adding 14 grams of powdered drink mix to 22 ounces of water. So that means that for every one drink is equal to 14 grams of mix over 22 ounces of water. Okay. So I want to figure out, okay, well, if I want to make, Y drinks, where Y is just some random number, but I need to maintain this ratio of 14 grams of mix over 22 ounces of water, well, then I need to know what happens when I input some value X, which is grams of mix, some random value X. If I put in some random value number of grams of the mix, how much water do I have to then put in to keep this ratio of 14 grams over 22 ounces? And then vice versa, right? I need to know what happens if I put in some random value N ounces of water. How many grams do I need to maintain this ratio? So all you got to do is, well, I know that 14 grams of mix over 22 ounces of water maintains one drink. So let's say X grams over N ounces of water is equal to 14 grams of mix over 22 ounces of water. So any value of X that I put in here, grams, I can then divide on the left hand side and then on the right hand side, and that will then well, let's write it out, right? So let's simplify this. Let's remove the units, so I can say X over N now is equal to 14 over 22. We want to write a formula that expresses the amount of water in ounces N needed to make the sports drink using X grams of powdered drink mix. So let's say we had X. We already know X. We want to find N. Right? So all I need to do now, we can flip the fraction. So we can say N over X is 22 over 14. You can see that this is true if you just cross multiply and divide. And now to solve for x, just to solve for n, to multiply by x on both sides. So n over x times x. These x's cancel out on the left hand side, and then I just have 22x over 14 cancels. So then n is equal to 22x over 14. Okay, for part B, we have a picture that's 4 inches wide by 9 inches tall. We want to scale it without distorting it, so we want to keep the same ratio here. So if that's the case, we can do the same thing that we did before. It's just creating a proportion. So if the initial ratio is 4 inches wide by 9 inches tall, and I want height and width in terms of h and w, then I can say that this is w over h. So we have a ratio. We've created a ratio of width over height, which is 4 over 9. So we have a ratio that we want to maintain. Now we want to solve for h. So we can just again flip the fractions, right? So h over w is equal to 9 over 4. Multiply by w on both sides tells us that h is equal to 9w over 4. Nice. Okay. Number 3. Y varies at a constant rate of change of 2.9 with respect to x. So I'm saying that the change in y with respect to the change in x is 2.9. Remember that when I say the change in something, I'm saying y final minus y initial, or I'm saying y2 minus y1. So I'm taking the distance or the difference between 2 points. Okay, the same thing for delta x, right? This delta, this triangle means delta, which is just the change in something. All right, we're told that y equals -5 when x is 8. So we'll say that our initial conditions, x initial 8, y initial is -5. We want to know the value of y. So y final is question mark when x final is equal to 10. So the first thing that we want to know or note is that solving for y final, I know delta y is y final minus y initial. I know delta x is x final minus x initial. So if I want to solve for y final, I want to get all the y's to one side, all the x's to the other side, or everything else to the other side. So I'll multiply by delta x here on both sides. So then delta y is equal to 2.9 times delta x. We can plug in the fact that y final minus y initial is delta y, and the same thing for delta x. Make sure to put a parenthesis here, right? Because you're not just multiplying 2.9 to x final, you're multiplying it to the entire term. And then we just plug in our values and solve for y final. So we have y final minus y initial, where y initial is -5, so minus -5 equals 2.9, 10 minus 8, which tells us then y final plus 5 is equal to 2.9 times 2. So y final should be 2.9 times 2 minus 5. .9 times 2 minus 5. Okay. Cool. B. Candle's lit and burns at a rate of 0.6 inches per hour. We're told that 3.5 hours after the candle's lit, the candle is 9.4 inches long. So let's say we have some function f of t, where f of t is the height of the candle. T hours after T hours since it's been lit. Since lit. Okay. we can write this as the initial height minus the rate at which it burns, so 0.6 times T. We don't know what A is yet, but we're told that 3 hours after it's been lit, so f of 3.5, right? So we have a function f of T, where T is the number of hours since the candle was lit. The candle is 9.4 inches long. So all I need to do here, plug in our T and our Y, or our f of T into here, and solve for A. So say 9.4 equals A minus 0.6 times 3.5. Now A must be 9.4 plus 0.6 times 3.5. Okay, we're told that gas weighs 6.3 pounds per gallon. And we're told that when the gas tank contains 2.7 gallons of gas, the combined weight of the motorcycle and gas in the tank is 367.01 pounds. So we're told that W total equals the weight of the bike, so WB plus the weight at 2.7 gal. Okay. So, to find the weight of the bike, we're going to plug in our total weight here, which is 367.01. And I need to figure out what this weight at 2.7 gallons is. So I'm told that there's 6.3 pounds in 1 gallon, so I want to know how many pounds there are in 2.7 gallons. So we can do dimensional analysis. If I take 2.7 gallons, I want to convert that into pounds. Right, I know 6.3 pounds over 1 gallon. 6.3 pounds is in 1 gallon of gas, right? I have gallons divided by gallons. So technically, if you're doing dimensional analysis, if you've taken chemistry 1, have you seen this? The units for gallons will technically cancel out, right? And then we're really just left with 2.7 times 6.3 pounds. That's just to make sure that the units check out, right? Because we want an output in pounds. So then I have 2.7 times 6.3, which is 17.01 pounds, right? Okay. I want total weight. Or I'm sorry, I want the weight of the bike, right? It's gonna help us for B. So weight of the bike in this case, since we're told that the total weight at 2.7 gallons is 367.01, then the weight of the bike plus the gas weight, which is 17.01 pounds, implies the weight of the bike must be equal to 367.01 minus 17.01, which is 350 pounds. Okay. A wants to know what? A wants to know the combined weight when the gas tank contains 5 gallons of gas, right? Okay, well, 5 gallons of gas times 6.3 pounds per gallon. Gallons will cancel out again, right? And then we just have 5 times 6.3 pounds, which gives us what? 31.5. 31.5 pounds. This is the weight of the gas when it's 5 gallons. Right? So now, combined weight, this is A. Combined weight is the bike weight plus weight at 5 gallons. Okay? I know the bike weight is 350 pounds. And I know the gas weight is 31.5 pounds. So that means that the total weight has to be 381.5. For B, if I want to write a formula that expresses the combined weight in pounds of the motorcycle in terms of the number of gallons of gas N, or V, I'm sorry, then I have total weight, or WT we'll say is lowercase w, which we know is the weight of the bike, plus some weight sub V, where I'm saying the weight at V pounds, or the weight at V gallons. Well, I know the weight of the bike is 350, and I also know that if I were to take the ratio that we have, 6.3 pounds per gallon, multiply that by V, where V is the number of gallons of gas, then that'll be a correct output, right? Because V is going to be in terms of gallons of gas. Units will cancel out. We'll get an output in pounds. So I'll have the total weight is just 350 plus 6.3 V. That's W. And this is also our answer for A. Okay. 31.5, 350 plus 6.3 V. Okay, number 5. Y is a function of x, and we call this function f. So f of x equals to y. F of 4 represents what? Well, I have a function of x is equal to y. So I'm saying f of x, f of 4, when x is equal to 4, f of 4 is what? I'm saying f of x is y, so f of 4 must also be equal to a y value. So it means that f of 4 should be the value of y when x is 4. If f has an inverse function, right? Remember what an inverse function is? 5b. If we have f of x equals y, then f inverse of y is x. So then f inverse of 4 also equals x, which means that f inverse of 4, which is a y value, equals to some x value. So f inverse of 4 represents an x value when y equals to 4. Nice. Okay. Number 6. We want to talk about a practical domain for this candle problem, right? So an 11-inch candle is lit, burns at a rate of 1.4 inches per hour. We're given a function f of t equals 11 minus 1.4 t. Obviously we can have 0 hours, right? T is the number of hours since the candle was lit, so they can not have been lit yet, right? It's 0 hours. Or it could have been completely lit. So for a candle to have completely lit, right, that would have to mean that f of t, which is our height, has to equal to 0, right? So I need to figure out for what value of t does the function equal 0. So I'm going to set the function equal to 0 and then solve for t. So then 11 equals to 1.4 t, which tells me that t is equal to what? I don't know. 7.857. Okay, so then our practical domain, remember domain is all the values of x, or all the input values that we can take on. In this case, that's t values. All possible t values. So our t values are 0 to 7.857. Let's add an extra decimal to be safe. This wants our answer as an inequality involving t, so then we'll change this from interval notation to inequality notation. That's that. Practical range is all possible y values. or f of t values, which in our case is all the heights of the candle, right? So the candle starts off 11 inches tall and ends being 0 inches tall, right? Because it gets completely burnt out. So that means that 0 is less than or equal to f of t, which is less than or equal to 14, which says that our interval, our range, is between 0 and 14 for the y values. Okay. C wants us to evaluate f inverse of 8. Remember again, we have an inverse function. That means that y is the input, x is the output. So if I'm saying I'm evaluating f inverse of 8, then I'm going to say, well, okay, I want to figure out x. I want to figure out when the function is equal to 8, what x value gives me that function, right? Well, okay, we know what the function is. It's 11 minus 1.4t. So I'll just set the function equal to 8, and I'll solve for t. I should have made this t. Sorry, guys. Because, right, this is a function of t. So then I'm going to say 8 equals to 11 minus 1.4t. So then 8 minus 11 equals negative 1.4t. So then negative 3 equals negative 1.4t. And then t has to equal to negative 3 over negative 1.4, which is going to be something a little bit under 2. Right, so 3 divided by 1.4. A little bit over 2, I meant, sorry. Which is going to be 2.1428. 2.1428. We'll say 2.9. We'll round up. Okay. And this number represents a number of hours, right? We solved for t. All right, let's plug in the answers that we just found, right? So 0 is less than or equal to t, which is less than or equal to 7.8571. Practical range goes between 0 less than or equal to f of t less than or equal to 14. F of negative 8 we said is 2.1429, and we just said that it's in hours. Oh, not 14, sorry, 11. Okay. Number 7. We want to know what happens as x increases without bound. So what does that mean? So we want to know as x tends to infinity, or as x gets larger and larger and larger, what happens to f of x? What does f of x do? So we're going to evaluate that for all these different functions, right? So a, we'll say f of x is equal to 1 minus x squared. Let's say I were to input a really, really, really large value into here, right? Let's just say f of 100, which isn't really large at all, but I mean that's really all you need to see what's going on with the function, right? If I input negative 100 squared, right? 1 minus a really, really big number. 100 times 100 squared, or I'm sorry, 100 times 100 is 10,000. Right, so this is going to be negative 9,999. If I input a larger number, like 10,000, it's going to be even larger negative number, right? So that would tell us what? That would tell us that as x approaches infinity, f of x, which is equal to 1 minus x squared, approaches negative infinity. Okay, so that means, right, f of x goes to negative infinity. For b, f of x is x squared minus 1. A really large number here. Is going to be 10,000 minus 1, which is 9,999. Which is, if I input a larger number than that, right, if I input like 100,000 for my x value, that's going to be huge, but it's still going to be a positive number. So then f of x tends to infinity as f of x tends to infinity, or increases without bound. X cubed is the same way. The reason for that is because x cubed is the dominating leading term here. It grows at a faster rate than x squared, so it's greater than x squared. It's also greater than negative 15x. It's also greater than negative 104. So if I input a large value of x into the x squared term alone, that would tell us what happens to the function as x tends towards infinity. So yes, if I input a large number, if I input like 100 cubed into here, well, if 100 squared is 10,000, then you have 10,000 times 100 again, which is going to be an even larger number, right? So x, as x tends to infinity, this entire function also has to tend to infinity. And then for d, I have f of x equals 1 minus x cubed plus x to the fifth. And we can use the same argument that we used for c, right? X to the fifth is the leading term. It's the term with the highest power for our input, x. So some really large number to the fifth power is going to make an even larger number, right? So that means that the y values have to tend towards infinity as f of x tends towards infinity. Now for b, we're going to say we want to know what happens to the function as x decreases without bound. So that means x tending towards negative infinity, decreasing without bound. And you might think, well, isn't it just going to be the opposite of as x increasing without bound? And that might be true, but it also might not be true, right? So you have to look. You have to input the values and see what happens. We're using the same functions, so I'm just going to rewrite a 1 minus x squared. So what happens when I input a large negative number into x? It is equal to f of x, just so we know. Let's say I input f of negative 100. Okay, I have 1 minus negative 100 squared, which is 1 minus, well, negative 100 squared is still 10,000, right? Which is still negative 9,999, 1 minus 10,000. So this still tends towards negative infinity. For b, I have x squared minus 1. It's going to be the same thing, right? Because if I square a negative number, it's going to give me the positive. So f of negative 100 here is going to be negative 100 squared, which is going to be 10,000 minus 1, which is 9,999. So then here x still tends towards positive infinity. X cubed, however, is a little bit different, right? So x cubed minus x squared minus 15x minus 104. Again, we're still looking at the leading term. The leading term tells us enough. So if I input a large negative number here, I want to know what happens to f of x, right? So let's again input negative 100. So f of negative 100 here is going to be negative 100 cubed. Okay, well, when you square negative 100, you get 10,000, right? That's 100,000. No, that's 10,000. Times negative 100 again to get cubed. Well, that's going to be a really large negative number. So that means that as x approaches negative infinity in this case, f of x also approaches negative infinity. And you can also just understand the curve of a cubic function, right? Sorry, this is really bad. Cubic function looks like this, where this is x, this is y. If these are negative x values and these are negative y values, then yeah, as I tend towards negative infinity, right, as x gets more and more out here, I mean, it doesn't matter, right, where x goes. I know that it's going to be a negative value because there's no positive values that exist for the cubic function in this domain, or in this quadrant of the graph, right? Okay, and then for d, again, we're just looking at the leading term, but I'll write out the whole function just for the sake of being thorough. X to the fifth is the leading term, so that's what we're focusing on again. We'll input a large negative number. Okay, well, negative 100 to the fifth is the same thing as negative 100 to the 4th times negative 100 again. Right, so this is going to be a positive number because you're taking two squares and multiplying them together, right? It's negative 100 squared times negative 100 squared, which are both positive because a negative times a negative is a positive. And then we're multiplying that by another negative. So this is going to be a really large negative number, right? So what does that mean? So as x tends towards negative infinity, then f of x is going to go towards negative infinity because it's a very large negative number. There we go. Question 8. Okay. So we have a rational function, right? And we're told that f of 5 is negative 20.6667, excuse me. Well, I mean by the nature of a rational function, right? I'm taking a function on top, I'm dividing it by a function on the bottom. This ratio, this function divided by this function, whatever output I get, is going to tell me that the top function is some number of times greater than or less than the bottom function, right? So if I input 5 here, that tells me that the top function is negative 20.6667 times larger than the bottom function when x is equal to 5. Obviously negative 20 is smaller, right? But that's the answer, right? So because of the nature of rational functions, right, if I'm saying I have 6 over 2, which we know is 3, right, I'm saying that 6 is 3 times larger than 2. Or 2 times larger than 3. Okay, so then this is negative 20.6667, and that's times large as the value of x minus 8. Number 9. If a child's height increases from 21 to 29 inches, what's that percent change? You need to know the percent change formula, which we've talked about in recitation a couple of times. Just you should really write these down if you don't have them already. Y final minus Y initial over Y initial times 100%. Our Y final is 29. Our initial is 21. So it's going to be 29 minus 21 times 100%. We can just input this the way it is. We find out that that's 38%, a change of 38.09%. Okay, submit that. That's correct. So that's part A. I'll label it A. Part B says that we're starting with a bank account that has $1,450, $1,450, and that increases by 5%. What's the new balance? So we could either do two things, right? Our growth factor in this case, right? Our growth factor B would be what? I want an increase of 5%. So I know that 5% is 0.05 in a decimal form, right? But if I take $1,450 and I multiply it by 0.05, that's going to give me 5% of $1,450, which doesn't output the new balance. It outputs the value that I'll add onto the original balance to get the new balance. Instead, if I want, I could use our growth factor of 1.05, right? Take our initial value, 1450, and multiply it by our growth factor. And this will give me the new balance. Or we could also just say, okay, I know that I start with 1450, and I need to add 1450 times 5% of 1450. Now take notice also, technically, this 1450 plus 1450 times 0.05, I have two terms of 1450 here that can be factored out. So I can say 1450 in big brackets is 1 plus 0.05, right? Which is just 1450 times 1.05, which is our growth factor. So you could write it like this, which is the long way, or you can just simplify it and rewrite the percent increase that we want as a growth factor. So, right, because you always start with 100% of something, and I'm saying I want to increase that by 5%. So that's 1.05. Okay, so whatever that is, we can input that. That should give us the correct answer. And it does. And then C, pair of jeans is on sale for 35% off, and that means that the jeans are now $55. So $55 after 35% off. What was the original price? Okay, well, if something's 35% off, that means we're starting with 100% of something, taking off 35%, which means that its value is 65% of its initial value. So, that means we're taking some initial value, A, we'll say A is our original price. If you hear some background noise, it's my dog snoring, I'm sorry. So we're taking that initial price and we're multiplying it by 65% of itself, and that outputs $55. So to solve for the initial price, all I need to do is divide $55 by 65%. This will give us the original price. In dollars. Okay, and it turns out to be $84.62, just about. Okay, we're getting not exactly halfway done yet, but almost there. Alright, number 10. We're starting with 10 micrograms. Let me make sure I write A. 10 micrograms, and we're saying it doubles every hour. Doubles every hour. Okay, we want to write a formula that expresses the mass in terms of the number of hours T since the beginning of the experiment. So M, the mass, equals the initial mass, which is 10. We know that it doubles every hour. So 10 times 2, if we're doubling every hour, that means after 1 hour, it'd be 10 times 2. After 2 hours, it would be 20 times 2, which would be 10 times 2 times 2. After 3 hours, it would be 10 times 2 times 2 times 2. So then for T hours, it would be 10 times 2 to the power of T. Okay? Which means that our final answer is just exactly what I have here. I don't know why I rewrote it. I just wanted to remove this dot. So the mass is equal to 10 times 2 to the power of T. 10 times 2 to the power of T. Okay. We want to know after how many hours will the mass be 2,560 grams. So then we just say the mass is 2,560 grams. I know what our function is. Let's solve. Right? We'll divide by 10 on both sides. So now I have that 256 is equal to 2t. Here we can just do a log, right? So base answer exponent, we're going to have log 2 of 256 is equal to t. We can plug that in here. Which is 8 hours. So, right, because 2 to the 8th is equal to 256. Alright, B. Bradley plants a magic beanstalk that's initially 3 feet tall, and that grows 23% daily. We want to express a function of the height in terms of the number of days since it's been planted. So we start with 3 feet and we're increasing by 23% daily, right? So we can write our growth factor as 1.23. Remember, technically this is an exponential function, a b to the x, where a is our initial value, b is the growth factor, and x is the input. We've talked about this a lot in recitation. In this case, instead of x we have t, right? Our initial value is 3 feet, our growth factor is 1.23. So this is our function. Okay, and then for the second part, we want to know how many days after the beanstalk is planted will be 1,600 feet tall. Well, we know that h of t is our height. So I can just say, let's set the function equal to 1,600, and we can solve for t. Again, we can divide 1,600 by 3 first. And then we can just take a logarithm, right? So base, answer, exponent. Our answer is going to be the log base 1.23 of 1,600 over 3 is equal to t. And that answer, we can just plug this itself into iMath. Okay, and then log 1.23, 1,600 over 3. Turns out to be 30 days. Awesome. Number 11. This is just converting exponential to log and log to exponential. So a, b, let's say let's say ax equals b. Okay, and then we'll just do the conversion to logarithms. This is just general form, and then we can do the parts, right? So base, answer, exponent, it's going to be log base a of b is equal to x. This is going to be the sort of interchangeable formula that you can use to solve these problems. Just think, starting from left to right with the exponential form, I'm going to use what I learned in high school is an acronym BAE, B-A-E, base, answer, exponent. So this is going to be my base, this is going to be my answer, and this is going to be my exponent. So base, answer, base is b. That's confusing because I have actual values here for b. That's fine. I'll actually write out the word base, ans, exp. So this is our base, right, like we said. This is our answer, and this is our technical, quote-unquote, exponent. Okay, so then 3 to the 7th equals 2,187 is actually log base 3 of 2,187 equals to 7. And similarly, that means that log 5 of 3,125 equals to 5 can be written in the form 5 to the 5th is equal to 3,125. Alright? So then this is our base. This is 2,187. This is 7. That's not 7. That's 7. 5 to the 5th, 3,125. Number 12. So suppose that f of x is 3x plus 4, 3x squared plus 4, and g of x is 2x plus 8. We want to know f of g of negative 2 and g of f of negative 2. Right? Well, first of all, what does this even mean, right? Composition of functions, f of g of x, or as you may know it, f of g. F is a function of g of x, meaning that its input is g of x, and we output f of g of x, whereas g is a function of x, because g takes an input x and just outputs g of x. So I'm saying I know what g is. If I input x, if I want to know what f of g of negative 2 is, I'm going to input negative 2 into g of x first, figure out what the actual value for g of x is, and then g of x, that output that I find for x is equal to negative 2, that output corresponding y value, is my input for f, which then tells me what the entire f of g of negative 2 is. Right? Vice versa, when we do the second part, I'll first figure out what f of negative 2 is, and then plug that into g to figure out what that value is. So let's do this first, right? So f of g of negative 2. First of all, g of negative 2 is what? 2 times negative 2 is negative 4, plus 8 is just positive 4. So now I'm looking, instead at f of g of negative 2, I'm looking at f of 4, right? Because g of negative 2 is 4, is equal to 4. Now, f of 4 is just 3 times 4 squared plus 4. This is 3 times 16 plus 4. This is 48 plus 4. And this is 52. F of negative 2, first of all. 3 times negative 2 squared plus 4. 3 times 4 plus 4, which is 16. Right? 3 times 4 is 12, plus 4 is 16. So now I'm looking at g of 16 instead. G of 16 is 2 times 16 plus 8, which is 32 plus 8, which is 40. So these are our answers, 52 and 40. Nice, okay. Second part, right? We're given a table. I want to know what j of k of 2 is. Well, okay. The first thing I need, right, is k of 2. Well, let's come over here to x. I want to know, okay, x is equals to 2. What's k of 2? Well, k of 2 is 3. So now instead of j of k of 2, I'm looking for j of 3. So now I'll come over to 3. I see that when x is equal to 3, j of 3 is equal to 0. So that means j of k of 2 is equal to 0. Now k of j of 2 is equal to, first of all, what's j of 2? Go over to 2. J of 2 is 2. So now I'm looking for k of 2. We already know k of 2 is 3 from above. So these are our two answers. Okay, 13. We're told that 360 degrees and 2 pi are the same thing as 1 full revolution. 360 degrees over 2 pi can be simplified 2 pi radians, can be simplified to just 180 degrees over pi radians if we just divide by 2, right? So this is going to be a conversion factor between degrees and radians for us. So if I have 5.5 radians, I want to convert to degrees, we'll use dimensional analysis again. I want to have the unit that I want in the numerator and the unit that I'm getting rid of in the denominator. So I'm multiplying by radians, and radians is in the denominator from our conversion factor, right? So radians will cancel out here technically. And I'll get an output in degrees because that's all that's left. So I'll have that 5.5 times 180 over pi, 180 degrees over pi, is going to be some output in degrees. We can find out by just plugging in here. 315 degrees. And then converting 120 degrees to radians, we'll flip the conversion factor, and now I'll have 180 degrees in the denominator because that's what I want to cancel out in units. Right, so the degrees here will technically cancel out. So I'll have 120 pi over 180, which is the same thing as 2 pi over 3. Okay. And that's 2.09 radians. Okay. Alright, let's move on to question 14. So let's draw a picture for A and B. So the initial ray points in the 3 o'clock direction, so we can make the initial ray, right? And the angle's ray subtends an arc that's 3.6 centimeters along, 3.6 centimeters long along a circle, counterclockwise, with a radius of 3, centered at the angle's vertex. Okay. So I'm just going to make some random angle, right, because I don't know what the angle is. We're going to solve for it, but I'm going to make some random angle, and then we can make a circle. So I'll get this out of the way. We'll center this angle, and I will basically erase the rest of this because I'm just concerned with the angle that the arc that the angle makes. Right, so I have some arc. We'll say that this is 3.6 centimeters long, and the radius is 3 centimeters long, which means that this is also 3 centimeters long, right, because we're a long circle. And we want to figure out what? We want to figure out theta. Okay, well, we need to make use of the formula for arc length, which is S is equal to R times theta. I would write this down if you don't have it also. Right, so S is your arc length, R is your radius, theta is your angle in degrees or in radians. So in this case, we want to solve for theta, right? If I have S is equal to R theta, well, to solve for theta, I'm just going to divide both sides by R, which is just theta, right? So then theta equals S over R, and plug in the values that I have, right? So I have 3.6 centimeters over 3 centimeters. Which ends up being 1.2 centimeters, or not centimeters, sorry, which ends up being 1.2 radians. Okay, so 1.2. Right, and then part B. An angle's initial ray points in the 3 o'clock direction, has a radian measure of 2.2, and a circle with a radius of 4.2 centimeters long is centered at the angle's vertex. what's the length of the arc that the angles rays subtend? So here we're given a radius and we're given theta, an angle theta. So I'm just going to copy and paste the same diagram and I'm just going to replace the numbers. Alright, so let's fill in the information that we have, right? So I have a radius of 4.2 centimeters. Since we're along a circle, then the terminal angle and initial angle, or terminal ray and initial ray, have lengths which are the radius, right? Because we're along a circle. And then we're given that theta has a radian measure of 2.2. So theta is equal to 2.2 radians. I want to figure out what this arc length is. Well, right, we're just going to use the same formula. S is equal to r theta. Except now, we don't have to do any manipulation, right? Because we're solving for S. So all I got to do is plug in the numbers that I have. 4.2 centimeters times 2.2. We're actually not going to keep the units of radians. We know it's radians, but it's just to make the units work. Not going to include it in the calculation. So our arc length should be 9.24 centimeters. Okay. Move on to question 15. Really the thing is, as long as you can remember a lot of these general formulas, you could really be okay. It's just knowing, what do I need to identify in the problem, based on the formula that I have, like what can I plug in? As long as you understand the formula, you're in good shape. So now I have an angle's initial ray pointed in a 3 o'clock direction. We're told that the angle measures 0.42 radians, 0.42 rads. We're told that the radius is 2.5 centimeters. If you hear my dog in the background, I'm sorry. What else are we told? That's it, right? We want to know how many radius lengths to the right of the circle center is the terminal point. So the terminal point, right, is this point right here. It's the point on the terminal ray, which is also along the circle. So, well, what information do we need to figure out what this value is, right? What do we know about finding points on a circle? Like, how do I figure out what x comma y, right? If this is an x, y graph, plane, how can I find points given a function? Obviously, like if I had the values, the tick marks here, sure, I could evaluate what the x and y values are, right? But for a general circle, right, we know that x comma y is equal to r cosine of theta and r sine of theta, right? So we can use this information to help solve our answer for probably all these questions, but specifically right now just for A. So first of all, we need to figure out what's the x value, what's the x coordinate for this terminal point, right? And to do that, I need to fill in the formula for x, which is equal to r cosine theta. Right, I know r is 2.5 centimeters times cosine of 0.42. Right, because the answer that I get here is 2.28 to 7, we'll say. Right, and like let me try to put that in as the answer. Obviously that's wrong. If that's not obvious, I'll explain why, right? This is an answer in centimeters, right? And it's also just an x coordinate. So I'm saying that if I have a circle, right, and I have an xy plane, this is our terminal point. I'll put it in. That's not, that's fine. Okay, that's better. right? I'm saying that this x value, because if this is the xy plane, maybe I'll do it in green. I'm saying that x comma y here, I'm saying, well, the x value I know is 2.2827 centimeters. I don't know y yet. We're not concerned with y yet. We're not trying to solve for y. The question is asking for an answer in radius lengths, right? Well, what do I know what the radius length is? I know that the radius is 2.5 centimeters. So I'm asking how many radius lengths is the terminal point from the center. So all I have to do, right, if I want to know how many radius lengths are in 2.2827 divided by the radius, I'm going to divide this value by the radius, because this is blank times as large as the radius itself, right? So 2.2827 centimeters divided by 2.5 centimeters, which is our radius, is equal to 0.91308. Probably could round up to 0.9131. Oh, sorry, that should actually be here. Right? So I'm saying that the x value here is 0.91308 times larger than the radius, right? And obviously, yes, it's less than, because it's a number less than 1. And the ratio is less than 1. Right, we're taking a ratio of two things. It tells you how much larger one is than the other. And that's exactly what we're looking for here. We're saying if I were to take whatever measurement in centimeters that I have here, if I want to figure out how many radius lengths is it to the right of the center of the circle center, then I'm going to divide it by the radius. Okay. Now B is asking how many centimeters is that value to the right of the center circle, to the right of the circle's center. Right, and we found that out already. It's 2.2827. That's the actual value in centimeters. Okay, now C is asking above the center, circle center, right? So that is where the y values come in. And if we look up here, right, well, we know that y is equal to r sine of theta. So in order to figure out what y is, you can just plug in the same way we just did. So our radius is 2.5. And it's taking sine of 0.42 in radians. The output here, 2.5 sine 0.42, 1.0194. Okay, so this is the answer in centimeters, right? I think we could also literally just say sine of 0.42 instead of having to do that whole long-winded piece, right? I could also literally just say, okay, how many radius lengths is it to the right? I can just say, well, it's cosine of 0.42, because that doesn't take into account the radius. So we're actually kind of doing an extra step here by doing r cosine of theta, trying to find how many radius lengths larger it is. If I wanted to just plug in the cosine for radius lengths, that's fine. And then if I wanted to just multiply that cosine of 0.42 by the radius, that would give me the same answer. I mean, it's the same thing that we're doing, just thinking about it really quick. Okay, so now for D, right, all I need to do, it's this value, right? So it's 1.0194. So I'm saying, how many centimeters is it above the circle center? Well, I know how many radius lengths it is above. Let me just multiply our radius lengths by the radius of the circle, which is 2.5, to now figure out that value in centimeters. Okay. Okay, question 16. So we're boarding a Ferris wheel at 3 o'clock position and rotating counterclockwise. So the fact that I am saying I'm on a Ferris wheel for one, we're boarding at a 3 o'clock position and rotating counterclockwise, right? Obviously we're talking about movement on a circle. So, okay, we're still working with the unit circle. Still working with general trig, that we're familiar with. right? So this is an x and a y. We know that the radius is 12 meters long, and the center of the Ferris wheel is 19 meters above the ground. Okay? So actually, I'm going to do something to this graph, right? So if this is 0, let's just say this is 19. We're saying that the center of the circle, or the center of the Ferris wheel, is 19 meters above the ground. Okay? So really, what would make more sense is instead of having this circle centered at 0, it would make more sense to have this circle centered at 19. Because I'm saying that the center of the circle is 19 meters above the ground, right? So if that's the case, then really I have a circle centered at y is equal to 19 and x is equal to 0. Okay, so I'll actually just drag these down like this. Okay, that's fine. And I'll make a dotted line at 19 just to show that this is sort of our new origin, I guess. Okay. Imagine an angle with its vertex at the center of the Ferris wheel that subtends the path that Ariana has traveled, and let theta represent the varying radian measure of this angle. Write an expression in terms of theta to represent Ariana's varying distance to the right of the center of the Ferris wheel in meters. Okay? Well, here's the information that we know, right? So we know that the radius is 12 meters. The distance above the ground is 19 meters. Right, when I'm saying 12 meters, I'm saying this entire piece right here, the radius of the circle. Right, because the radius is, maybe I should move the circle a little bit more up. It's not perfectly centered. Right, that makes more sense. That looks more like a radius. I guess that may be a bit more clear. So right, if I'm talking about varying distance to the right of the center of the circle, we're talking about a coordinate. Right, again, we're talking about r cosine theta, r sine theta. To the right of the center of the circle means that we're talking about an x distance, a horizontal distance, right? So we're still working with x is equal to r cosine of theta. We want an answer in meters, so the r is going to come into play. So we're just going to plug in. So our radius is 12, right? 12 meters times the cosine of what? The cosine of theta, right? We're told to write an expression in terms of theta. So I don't actually have a value to plug in for theta. So really this answer should just be 12 cosine of theta. Okay, and maybe this isn't obvious, right? You might think, well, why don't I add 19 to that? I'm just talking about an x value, right? Alright, so this is the answer for A. Well, let me be more specific. This is not the answer for A. This is the answer for A. Actually, right, so I'm just talking about an expression. If I was talking about an equation, then yes, I would say x is equal to this. But just saying an expression, right? I'm just saying, well, then I just need to have this piece here. The meters isn't really important, right? That can go away. I'm just putting that there to show you that it's going to be an output in meters, right? Because I'm multiplying by meters. Alright, for B. Alright, so now for part B, if we want to write an expression in terms of theta to represent the varying distance above the center of the Ferris wheel, right? Well, you know that y is equal to r sine theta. And then the only difference here is that instead of the center of our Ferris wheel being at y is equal to 0, this is where it typically is, right here, we are instead shifted up 19 meters. Right? Let me do it in red. We instead shift up 19 meters. So, typically when you are representing a vertical shift for a function, right? Let's say I have some function x squared. I want to shift that function up by some constant c. Well, then I would take that function, right? And I would say plus c is x squared plus c plus some constant. So we're really looking at y is equal to r sine of theta plus 19. Okay? And this is technically y plus 19, but we're just going to write it as y. Maybe not technically y plus 19. I would just write it y is equal to r sine theta plus 19, right? So we can just represent this generally as y is equal to r sine of theta plus some c. So where c is defined as the center of the circle, or distance above the ground. Or we can say vertical shift from origin / distance above ground. Okay? So then this is our answer for B. Except the only difference is that when we plug in for y, or sorry, for r, right? This is 12 sine of theta plus 19. Oh, sorry. This says we want the distance above the center of the Ferris wheel. So if we're just talking about the center of the Ferris wheel, distance above the center of the Ferris wheel, right, then we're just talking about the y value on the circle. So this is saying, part B is saying, the distance above the center of the Ferris wheel. So the center of the Ferris wheel we know is here at 19 meters, right? So here I'm just saying, okay, if I have some point here, if I want that y value relative to the center of the circle, that's just taking the sine of theta, right? R sine of theta. But if for C, we want to represent the varying distance above the ground in meters, right? Well, then I would have to add that plus 19, because I'm saying I have this y value, but I also need to add in this distance from the ground. So it depends on what distance we're measuring relative to what. Relative to the center of the Ferris wheel, okay, then we're just talking about the y value on the circle using just the general r sine theta formula. But if we're talking about distance above the ground, then it's that general r sine theta formula plus that vertical distance shift that we have. Okay, so then really for B, it's just 12 sine of theta. And then for C, right, we take into account that we're saying relative to the ground, above the ground. So then it's r sine of theta plus that vertical shift, which in our case, our radius is 12 sine of theta plus 19. All right. 17. Okay, a rocket is launched from the ground at an angle of 0.4 radians, and the rocket travels in a straight path. Okay, so let's draw that. Let's just draw, I'm going to draw an angle. This may not be accurate to 0.4 radians, and that's fine. I'm just using it as a reference, right? So I'm saying that we have some rocket. We'll say that this is the rocket. Or we'll say this is our rocket. Okay. and the rocket travels in a straight path, so it's going to continue going this way. We want to know the slope of the rocket's path. Right, so how do we figure out the slope of this path? Well, what is the slope, right? Slope is defined as delta y over delta x. You could say slope at a point could just be y divided by x. So then if we want the slope y over x, right, if this is our x, and then our y would be whatever this vertical distance is here, right, then I would need to figure out, okay, how do I find what these x's and y values are? How do I plug them into the function? Or how do I plug them in using the fact that we have an angle swept out at 0.4 radians to then figure out the slope? And what's interesting here is, I mean, we know, right, if we're talking about movement along a circle, I mean, not even we don't even have to talk about circles. If we just use trigonometry based on the orientation of a triangle, right? I know that if I have a triangle, well, maybe I could I'll do ink to shape, maybe that'll work. Cool. I know that if I have a triangle with some angle theta, right? This is x, this is y, let's say this is z. Right, if I want to figure out what y and x are, well then I can take the tangent of theta, right, which is the opposite over adjacent sides, right, if you know SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Well, the opposite angle from theta, or the opposite side from theta is y, and the adjacent side from theta is x, right? Because this is the hypotenuse, so this can't be the adjacent side. This is x. So then we know that we can represent the slope of the rocket's path as the tangent of theta, which is equal to y over x. Now, what do we know as y over x? If we think about this in terms of the unit circle, right? If this were traveling along a circular path, let's say, well, we know how to figure out x's and y values for circular paths, right? We also could just say, okay, I mean, and this is the long-winded way of doing it, right? If I just assume that this is movement along a circular path, I can say, well, I know y is sine of x, or sine of theta, and cosine is, x is cosine of theta, right? But also, right, if I understand SOHCAHTOA, then I could also just say, well, sine of theta is equal to opposite over hypotenuse, which is equal to y over x. And I also know that cosine of theta is equal to adjacent over hypotenuse, which is equal to x over z. Oh, sorry, this should be z. So then if I were to do tangent of theta, this would become sine of theta over cosine of theta, which is equal to, this would become tangent of theta, which is equal to opposite over adjacent, well, I have opposite over adjacent, sorry, and then now I know that tangent of theta, which is equal to opposite over adjacent, which is equal to y over x. If I were to take my expressions that I have here, these two expressions, the sine theta is equal to y over z and cosine theta is equal to x over z, well, what I can do here, right, is I can say, well, I know sine of theta is equal to y over z. So to solve for y, I can just multiply by z. So z times sine of theta equals y. And in the case of cosine of theta, right, we have x over z. I want to solve for x, multiply by z. So then z times cosine of theta is equal to x. If I then plug in into the tangent of theta based on these values of y that we just solved for, right, I have z sine of theta over z cosine of theta, which is just equal to sine theta over cosine theta. That's the really long-winded way of doing it. I just wanted to show that to you just in case you do see that on a question. I don't know that you will, but we can find out, I guess. Maybe there's going to be a similar question on here, right? So after doing all that work, just for me to really say that this is what we're going to use to solve the problem, all I need to do now is input my value of theta into these two functions to get my tangent of theta, which is y over x, which is the slope that we're looking for, right? So I know that tangent of theta is equal to y over x, which is equal to sine of theta over cosine of theta. I also know that theta in this sense is 0.4 radians. That's the angle that the rocket sweeps out at. So all I need to do is plug in tangent of 0.4 radians. Now, you could also write this as sine of 0.4 radians over cosine of 0.4 radians, but for the sake of convenience, we'll just do tangent of 0.4, which happens to be 0.42279, which I'll round up to 0.4228. Okay. If the rocket has traveled 495 feet horizontally since it was launched, what is the rocket's height above the ground? Okay, well, we know that y over x is equal to 0.4228. So the slope is this. Let's just say that x was equal to 495, right? Because I'm saying that the horizontal distance traveled is 495 feet, and x represents a horizontal distance. Well, let's just solve for y then, right? So now I have y over 495 is equal to 0.4228. So if I were to take my slope and multiply it by an x value, which makes complete sense, right? I can make a function and say the y value is equal to some slope times an x value. This is just the function of a line, right? Then I can say that y is equal to 0.4228 times 495. And this should tell me the vertical distance of the rocket if it's traveled 495 feet horizontally. And it does, which turns out to be 209.286 feet above the ground. So this is part A. Well, let me be more specific. Yeah, this is part A. This is part B, and now we'll do part C. So this is 209.286. And then C, we want to know if the rocket's 265 feet above the ground, how many feet has it traveled horizontally since it was launched? So now I have y over x is equal to our slope, or y equals 0.4228x, and I know y, I want to find x, so we can plug in the value for y that we have. So 265 is equal to 0.4228x. From here, all I would need to do, right, is just divide by 0.4228 on both sides. So that would tell me that x is equal to 265 divided by 0.4228. And since we're dividing by a number that's less than 1, I would expect this number to be about double, or more than, a little more than double. right? And that's correct. So x is equal to 626 feet, 26.7739 feet. Okay. Now, I'm shocked that this is question 18. Finally getting a tortoise and the hare question. Thought we'd see that a lot sooner. So a tortoise and the hare are competing in a 1,200 meter race. The arrogant hare lets the tortoise have a 550 meter head start. So let's draw this right. So this is 0. This is where the hare is. We'll say that the tortoise is over here. This is 550 meters. And the total race distance is 1,200 meters. This is the finish. And this is the start. I'll just drag this up here. Okay, and we have, obviously this is a straight line. Doesn't have to be a straight line, but we're just saying this is the distance of the race, and these are the positions relative to the distance of the race. When the start gun's fired, the hare begins running at a constant rate of 8 meters per second. So the hare's rate of the hare's distance traveled can be modeled by a function h of t, where h gives the distance traveled by the hare, t seconds after the start of the race. Well, I know that the hare runs at a rate of 8 meters per second, so that means that h of t would have to be 8t, right? Okay. Now the tortoise's distance we can represent as t of t. I'm not going to rewrite that whole piece above, just know tortoise dist t secs t seconds after start. We know that the rate that the tortoise runs at is, or crawls at, is 6 meters per second, right? So 6t, but the tortoise starts 550 meters into the race already, right? So this is 6t plus 550, right? Because if I just had 6t here, that would imply that the tortoise is starting at 0, and that's the distance he's traveling from 0, but he's not, because this is his starting point. His starting point is at 550 meters into the race. So it's 550, which is his initial starting point, plus whatever distance he travels after that. Okay? Now for C, we want to know, or we want to write an expression in terms of t that represents the number of meters the tortoise is ahead of the hare. Right, so I'll take the distance that the tortoise is traveling, and I'll subtract it from the tortoise's rate. So that's going to be negative 2t plus 550. Or you can say it's 550 minus 2t. Okay. Now, to figure out who finishes the race first, right, what we can do is just take our two functions, and we can set them equal to the total distance of the race and figure out who finishes faster, right? So I can say 8t is equal to 1,200 because that's the total distance it takes. That's the total distance of the race, right? If I say that we're at the 1,200 meter mark, that means we've completed the race. And I can take 6t plus 550 is equal to 1,200. And I can solve for t in both of these equations. Whichever one has the a smaller value for t, obviously finishes the race faster. So t equals 1,200 over 8 in this case. And here, t equals 1,200 minus 550 divided by 6. All right, so let's quickly put these into the calculator. We'll figure out which is smaller. 1200 divided by 8 is going to give us 150 seconds versus 1200 minus 550 divided by 6, which is 108.33 seconds. So that means actually the tortoise finishes the race first. We can plug in the other values that we have here, right? So this is going to be 8t, we knew, and this is going to be 6t plus 550, and this will be 550 minus 2t. Okay. The value of r is varying at a constant rate of change with respect to s. Okay. Okay, so we're told that r varies at a constant rate of change with respect to s, sorry. So that means that delta r over delta s, the rate of change between the two variables, or their slope, is constant. So this ratio will be some constant value, which we just need to solve for. Okay, so what do we know about delta r and delta s? What does delta mean, right? We discussed before that delta is the change between 2 points, right? So we said that delta of any variable can be represented as either r final minus r initial, s final minus s initial, or r2 minus r1 over s2 minus s1, whichever you feel more comfortable with. Let's look at this hint real fast. I just want to see what kind of output they're looking into. Enter delta x into the answer box to represent delta x. Okay. I believe that's what they're looking for part A. Or part B, sorry. That actually we have to answer part A first, which we didn't do. So this is A. This will be B. Okay. So if we're told that the value of r is varying at a constant rate of change with respect to x, right? With respect to s, sorry, then we know that whatever the slope is between any of these 2 points is going to be the same between any other 2 points. So I can just take the slope here between 8 and 14 and 3 and 1, and that'll be the same as the slope between 8 and blank and 9 and 3 and negative 19 and blank and 12 and 9. Or negative 19 and 14 and 12 and 1. So let's just do let's do 8 minus 14 over 3 minus 1. Okay, so this is going to be negative 6 over 2, which is going to be negative 3. So this is actually going to be equal to delta r over delta s, right? So now what we have is I have an output, or a value that I can replace delta r delta s with, and then I also know that delta r delta s is equal to rf minus ri over sf minus si. What I want to do is I'll use this 8 value as my r initial, this s value as my s initial. This is my s final, and then I want to solve for r final. So I'll leave r final as a variable. I'll subtract r initial, which we're going to say is 8, over 9, which is s final, which we're saying, minus 3. Okay, so now this is going to become r final minus 8 over 6 is equal to negative 3, right? Because we said delta r over delta s is equal to negative 3, which we just solved for here. So now what I can do to solve for r final is I can multiply by 6 on both sides, to get rid of the 6 in the denominator on the left side. And 6 times negative 3 is going to be negative 18. And then if I were to just add 8 to both sides, we can get our final, which we can see is just going to be negative 10. So that's the answer for A. B, we just found. I'm not sure what this is looking for, so I'm gonna do this. Hopefully this takes it as an input. If not, then I'll do something else. I don't know if that's gonna be the right answer. That's fine though. Either way, we can easily answer C now. We want to know the value of R when S is equal to 0. So I can say in this case actually we can use point slope formula. So if we remember this formula, x minus x is 0, right? This is the equation of a line, point slope formula. And we know that this table has a constant rate of change. We know that this table represents the function of a line, right? So all I need to do here, I know what m is. M is delta r over delta s, right? M is slope, and so is delta r over delta s, because that's our independent and dependent variables. So really I can rewrite this as r minus r0 equals delta r over delta s times s minus s0. And what we're looking for is the value of r when s is equal to 0. So we know that this is true. What we can do now is we can plug in any 2 points on the table, and that'll give us the equation of the line. And then we can use that equation of the line, plug in for s equals to 0 to figure out the y value, right? So I know that when s sub 0 is equal to 1, the function value is going to be 14. So that means r sub 0 would be 14. So let's plug that in. So I'll have r minus 14. I know that delta r, delta s is negative 3 from above. I have s minus 1. So let's expand, right? I have r minus 14 equals negative 3s plus 3. If I add 14 to both sides, I have r is equal to negative 3s plus 11. Oh, I'm sorry, plus 17. So now, if I want to figure out what the function is when s is equal to 0, well, negative 3 times 0 is just 0, plus 17, r would have to be 17. D is asking us to find a formula to represent r in terms of s. That's what we just did using point slope formula, so we actually kind of went a step ahead, which is completely fine. So C is, actually this is going to be D, right? We can say that C is going to be r of 0, which is equal to 17. Okay, and then E, the graph that represents, the graph that represents S in terms of R is linear. Yes, that's true, right? Because we have a constant rate of change. Linear functions are represented by y is equal to a times x, where a is just some constant. That's the function of a line, the equation of a line. It could also be plus some other constant, which is a vertical shift, right? But this a represents the slope. And this c is vertical shift. And that is the equation that we have, right? We have negative 3s plus 17. So we have a negative slope plus a vertical shift. So yes, it is a linear graph. Delta r is proportional to s. The delta s, that's also true. The graph of r in terms of s is a straight line that passes through the origin 0, 0. This is not true, right? Because the graph of this function starts at positive 17 and then goes down in a negative slope from there. So it's going to look something like this, right? There's no way for this function if it extends out infinitely to pass through the origin 0, 0. So no, this won't pass through the origin. This is r of s is equal to negative 3s plus 17. R is proportional to s. It's false. Ooh, did I do something wrong here? Maybe this just wants r is equal to 3s minus 17. Define a formula that represents delta r in terms of delta s. Oh, delta r is equal to negative 3 times delta s. Yeah, okay. That makes sense. So let's go back to B really fast. Define a formula that represents delta r in terms of delta s, right? So we found out that delta r over delta s is equal to negative 3, right? Which implies delta r over delta s is equal to negative 3. So this is asking for a formula that represents delta r in terms of delta s. So that means we want to function delta r in terms of delta s. So all we have to do with this is just multiply by delta s on both sides, which would tell us that we have delta r is equal to negative 3 times delta s. So we have a function delta r which is dependent on an independent variable delta s. So we have a function that's defined in terms of delta s, right? Because we have a constant times that independent variable. So this is your answer for B. Number 2 being false for part E. For something to be proportional to something, that means that, well, let's first off say, let's say if A was proportional to B, that would mean that A is equal to K times B, where K is a constant. What it means for something to be proportional is that they only vary by some factor of a constant. Meaning like K times B is equal to A, right? So A is a factor of K times B. So in the case of R and S, right, we have R defined as negative 3s plus 17. Clearly this isn't just R defined as some constant times S, right? This is some constant times S plus 17. So if this was R is equal to negative 3s, that would be proportional, right? Because I would have R defined in terms of K times B, where R is A, K is negative 3, and B is S. But we don't, right? We have R is equal to negative 3s plus 17. So R can't be proportional to S. Delta R delta S is proportional, right? Because we have delta R over delta S equals to negative 3, which implies that delta R is equal to negative 3 delta S. We do have that format of A is equal to KB, where A is delta R, K is negative 3, and B is delta S. Okay, and then I explained why the function can't go through the origin, just based on the fact that we have our y-intercept at 0, 17. Alright. Question 20. Two relationships between x and y are shown below. Relationship 1 is represented by the blue solid graph, and 2 is represented by the red dashed graph. Which of the following are true? Select all that apply. Look at graph. The following are true. For relationship 1, y is a function of x. Well, if does the blue function pass the vertical line test? Yes. So yeah, y has to be a function of x. For relationship 2 though, obviously we fail the vertical line test, right? Because if I make a straight line at any point here, I'm going to have a y value at the same x value twice. So for x is equal to 2.5, for example, I have a y value at something a little bit less than 1 and something a little bit greater than 5, right? So that fails the vertical line test. This can't be a function if y is a function of x. If x is a function of y though, right, meaning that our independent variable is y and our dependent variable is x, then if we did a horizontal line test, right, this would be a function. So relationship 2, x can be a function of y. Alright. For 21, okay, for question 21, we're going to look at this table and we're going to evaluate the following expressions, right? So let's look at A first. we're looking at f of g of 9, right? Remember, the first thing that I'm going to do is I'm going to figure out what g of 9 is, and then whatever that is, I'm going to use it as my input for f. So let's come over here. When x is equal to 9, g is equal to 9. So now I'm looking at f of 9. Well, let's come back over here. F of 9 is 6. So that's A. This is going to be 6. B. F inverse of 2. So I'm looking for what? F inverse is typically defined like this, right? If some function f of x equals to y, then its inverse is f inverse of y is equal to x, right? So when I say f inverse of 2, I'm looking for an x value that gives me a function value of 2. So the only time that f of x equals 2 is for x equals to 2. So that would have to mean f inverse of 2 is equal to 2. For C, g inverse of 2, by the same argument, we're going to look here at g of x, which equals 2 here, and that's the only point where g of x equals to 2, and that also occurs at x equals to 2. Now for D, we're going to do f inverse of g of 6. So the first thing I'm going to do is I'm going to look and see what g of 6 is. G of 6 is equal to 6. F inverse of 6. So now I'm going to look at f inverse of 6. Okay. F inverse of 6 is 9, right? Because f of x equals to 6 when x equals to 9. Cool. Question 22. We're talking about percent changes. So we're looking at the percent changes in the prices of each item or service. So for A, right, we're looking at the price of a jar of peanut butter, which went from $5.99 to $6.99, $6.89, sorry. So remember, the formula for percent change, which is y final minus y initial divided by y initial times 100%. So in this case, our final y is going to be $6.89, right? Our initial y is going to be $5.99. So we'll just plug in these numbers, and then we'll multiply by 100%. Now we can input this entire expression into iMath. Just gotta make sure our format is right. And this turns out to be 15%. So a 15% change, a 15% increase in the price of peanut butter. Okay, question B. Cost of a haircut was reduced for a holiday weekend from $13.99 to $7.99. So y final in this case is going to be $7.99. Y initial is going to be $13.99. Then we're going to multiply by 100%. Right, so obviously here we have a smaller number divided by a bigger number divided by a bigger number than the y final. So this is going to be a negative percent change. You should also know it's going to be a negative percent change, right? Because the initial value is greater than the final value. So I mean, I could just copy this entire expression here, just replace the numbers. 7.99 minus 13.99 over 13.99 is negative 42.9%. These are right. We'll do these in a second. So it's 39.95 to 43.99. So then this is a 10% change. Okay? So then again, I'll do, 43.99 minus 39.95 over 39.95 times 100%. Okay, D. So initial price $24,899. We go from that to $22,959. What's the percent change? So 22,959 minus 24,899 all over 24,899 times 100%. Okay. This turns out to be 22,959 minus 24,899 divided by 24,899 times 100. Okay, so this is a 10% increase for C, and this is a negative 7.79% decrease in D. Okay, got 4 more questions. We're almost done, guys. I know this is a really long video, but I'm hoping that it's helpful. You know, obviously you don't have to watch the whole thing. If there's specific parts that you're struggling with, you know, you can skip to those parts. All right. 23. So this is saying we have a car that's worth $11,000 at the beginning of 2000, and the value decreases exponentially, decreasing by 17% each year. Okay. So if we're decreasing 17% each year, that means what? That means that we're taking 100% of something, subtracting 17%, which would mean what? That would mean that we're taking 83% of the initial value, right? Because 83 plus 17 is 100. So to say something is 17% less than it was means that it's 83% of its initial value. So this is going to be our decay factor, B, right? This is going to be, right, we're saying that this is decreasing exponentially. So we do have an exponential function. The general form of an exponential function we've said is y is equal to ab to the x, where a is your initial value, b is your growth or decay factor, and then x is your input. So in this case, for A, we wanted to find a function f that represents the value of Lauren's car in dollars in terms of the number of years since the beginning of 2000. So we want a function f of t. So then we'll have some a, b to the t, right? We know what b is. We said that b is going to be 0.83, and the a is our initial value. The initial value of the car was $11,000. So $11,000 times 0.83 to the power of t, right? Because if I do 1 year, that's just 11,000 times 0.83. If I do 2 years, that's 11,000 times 0.83 times 0.83. 3 years is 0.83 times 0.83 times 0.83 times 11,000, and so on and so forth. So if you did t years, that would be 0.83 times 0.83 times dot 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 t times, which is the same thing as just saying, okay, let's raise 0.83 to the power of t. Okay. So this is your function for A. Now B wants to know how many years at the beginning of 2000 would the car be worth $6,000. So I'm saying I want to know for what value of t is the function going to be equal to 6,000. Well, we just have to solve for t then, right? So what I can do is I'll set the function equal to 6,000, and then I'll just solve for t. And this is easy, right? So what do we do here, right? First I'll divide 11,000 by both sides. So I'll have 6,000 divided by 11,000, which is then going to be equal to 0.83 to the power of t. Okay, 6,000 divided by 11,000 simplified is going to be 6 over 11. So now I have 0.83 to the t here. And then to solve for t, right, all I need to do is take a logarithm, right? So if we use base, answer, exponent, in this case, our base is going to be 0.83. Our exponent, quote unquote, is going to be 6 over 11. And then this is going to be equal to t. Right, so whatever this is, so we're looking for whatever value of t is going to give us 6 over 11. And we can find out what that is. So first of all, let's input what the function is, right? So we said f of t is equal to 11,000 times 0.83 to the power of t. And now we want to know, okay, what's log 0.83 of 6 over 11? Well, this is going to be 3.25 years. So really it's going to take 4 years, right? Because, well, you could say 3.25 years. That's fine. So yeah, t is going to be roughly 3.253 years. So that's a really quick reduction in value for a car. Okay, 24. I'm not going to write anything down for this one. I'll just write the number 24. Same thing for 25 because it looks like it's just a graph problem. So 24, when we say a function is either increasing or decreasing, and then in quotations at an increasing rate, what is this? What does the second half of the statement tell us for sure? So the function values over successive intervals are all positive. We can't say that for sure, right? You can have negative values for the function but still have a positive slope. So this I would not say is true. The function values over successive intervals are increasing. Yes, that's true, right? Because if the function is increasing or decreasing at an increasing rate, no, I'm sorry. I don't think this can be true either, right? We can say that the function values, we can't say the function values are increasing, right? All we know is that the function is increasing or decreasing at an increasing rate, which means that if it's increasing, it's further increasing, meaning it's increasing faster, or if it's decreasing, then it's decreasing faster. So these could be negative values that are just becoming more and more negative. That doesn't mean that successive intervals are increasing, or the values are successively increasing, right? The average rates of change, however, over successive intervals are increasing. And the average rates of change over successive intervals are all positive. Not true. Yeah, so the only one that's true is going to be C, right? So all we're saying here, so we're saying that if a function is increasing or decreasing at an increasing rate, that would tell me that the rate of change is not constant. That tells me that the rate of change is either increasing continuously, or if it's already a decreasing function, that decreasing function is then decreasing faster and faster and faster and faster. Okay, let's move on to 25. So we have the graph of two functions f and g shown below. We want to figure out how we can write a function formula for g using f. So f is the blue function, right? I want to write g of x in terms of f of x. So f of x looks like a cubic function. Doesn't really matter what the function actually is, right? Whatever, we have f of x. It seems like we're taking f of x, and to get the g of x, we need to first do a reflection over the y-axis, right? Because we're saying that we need to take this function, and I need it to look like this. So if I'm on the y-axis, if this is the y-axis, I would flip it over the y-axis to then have the graph itself reflect over that y-axis, right? So the first thing we're going to do is do a flip over the y-axis. And we need to figure out how do we represent that, right? So g of x, in this sense, there's two ways we could write this either. So if we're saying we're doing a reflection over the x-axis, let's say I have f of x, and I want to get a reflection over the y-axis. All that we need to do, right, is then say that g of x is equal to negative, excuse me, I'm sorry, that's not right. G of x is equal to f of x, f of negative x, right? So, for example, like let me look here at this function f, the blue. If I want somehow this function value, I want negative 6, 0, to end up here on the other side of the x-axis at 6, 0, well then what I need to do, right, is take whatever my x value is for g and just take the negative of that and say that the y value is the same. So that's exactly what we're doing. So I'm saying this is g of x, right? Or this is f of x, I'm sorry. If I want g of x to just basically be all of the x values of f of x, they're negative, or the opposite value, then yes, I'm just going to do a reflection over the y-axis, and all the x values will become positive with the same y values. So it's just a reflection over that y-axis. So then g of x is equal to f of negative x. That does the reflection part. Now the only difference is, instead of being instead of just doing a reflection, right, we also have a vertical shift here. So f of x, or g of x, is not only reflected over the y-axis, but it's also shifted down 5. So that means that g of x must be f of negative x. subtracted by 5. Okay? And then for b, we're defining f of x in terms of g of x. Well, it's just, it's exactly the same thing, just reversed, right? So then f of x will be the negative of g of x plus 5. Okay. So something to take note of is the fact that reflections over the y-axis, f of x is equal to negative g of x. Over the x-axis, just changes the y values from positive to negative. So an x-axis reflection will look like this. Right, let's say I had that same function like this. This is the x-axis. And all I want to do, oh, that's not really good. What's the best way to do this? I guess like that. Yeah, that works. So if I'm doing a reflection of the function over the x-axis, right, the only thing that's going to change is that I want these y values to now become negative. So I want all the y values of the function to just become their opposites. Then yes, I'm just going to say the function is defined as its negative y values. Okay, so these are two important things to note. Two more questions. Okay, 26. Okay, so this is easy, right? We just want to match these words to these symbols, right? So as x decreases without bound, f of x decreases without bound. So for x to decrease without bound, that means x tending towards negative infinity. The only options we have for those two things are c and d, right? As x tends towards negative infinity, we have f of x tending towards positive infinity, or f of x tending towards a negative infinity. We're saying here that x decreases without bound and f of x decreases without bound. So that has to be d, right? Meaning that as x increases, or as x decreases forever and ever, f of x also decreases forever and ever. So this is going to be d. As x decreases without bound, f of x increases without bound. The only other option there is c. As x increases without bound, f of x increases without bound. That has to be a, right? As f of x gets larger, or as x gets larger and larger and larger, f of x also gets larger and larger and larger, so it also tends towards infinity. And then the last one is just b. Okay. Last question is number 27. This is a tricky question. Okay. So we're given a graph of f. This blue graph is f. And then we're saying g of x is negative 5 over that function. And we need to fill in the following blanks. So I want the limit of g of x as x approaches 3 from the left for a. Okay? Here's what we need to write, right? So the limit is really of negative 5 over f of x as x approaches 3 from the left. Okay, well let's look at the function as we approach 3 from the left. This is 3. This is 3 from the left technically, right? Because this is all the function values to the left of 3. So let's see, as we come from negative infinity down to 3 from the left side, f of x approaches 0. So it's a really, really, really small number. It might not exactly be 0. So let's say it's negative 5 over some very, very tiny number that could almost be 0. I don't know exactly what it is, right? But this ratio, right, if I take a big number, or I take a whole number like 5 or 1 even, and I divide it by a really, 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 really tiny number, it's going to give me some huge number. And because we're dividing here by a negative, we can say that this is technically going to be negative infinity. Okay? And let's just be sure, right? So if I take negative 5, let's take negative 5 and let's divide that by 0.000001. Negative 5 million, right? That's a really big number. So that's one example, right? So that's going to be your answer for A. Now let's do the limit of g of x as x approaches 3 from the right, which is going to be the limit as x approaches 3 from the right of negative 5 over f of x. Okay? And remember, when we're saying the limit as x approaches some value, I'm looking for the behavior of the function as x approaches these values. I'm looking to see what the graph looks like it approaches as x approaches these values. When I say what the graph approaches, I'm saying the y values that the graph approaches as x approaches some x value. Okay, so now 3 from the right is the same thing, right? So if I come from the right, we're still approaching some really, really, really small number, which is probably going to be 0. So negative 5 over some really, 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 really small number, right? Again, is still going to be negative infinity. C is going to be the limit of g of x as x approaches infinity, okay, which is going to be the limit as x approaches infinity of negative 5 over f of x. Okay, well, let's look. Again, this is the blue graph of f. Whoops. As x approaches infinity, right? So as x gets larger and larger and larger as we go along the x-axis here, the function values are increasing and increasing and increasing forever and ever. So the function f tends towards infinity, right? So then I have negative 5 over infinity. Obviously, you can't evaluate infinity as a real number, negative 5 over infinity. It's not possible. But if I know that the function tends towards infinity, which is some really big number, then I technically have negative 5 over some really big number. Just as an example, let me put something like 1,000,000, right? And I know that this is going to be a very, 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 very tiny number, right? So if I were to do negative 5 over 1,000,000, so it's a really, really, really tiny number that's basically 0. So if I keep putting in larger and larger and larger and larger numbers, it's going to be a number that's increasingly and increasingly close to 0. So we can see that the limit as negative 5 over f of x, the limit as x approaches infinity of negative 5 over f of x is going to be 0. Okay, so we're saying that the function approaches 0 as x approaches infinity. Sorry, this is actually your answer for D. And then the limit as x approaches negative infinity, I think it turns out to be the same answer anyways, so it really doesn't matter. Well, let's look at it, right? So I have negative 5. As x approaches negative infinity, which means as x gets more and more negative, we see the function is still increasing, which means it's still tending towards infinity, which means, again, it's going to be negative 5 over some very large number, which is going to be 0. So these are our answers for our final question. Okay, we can input them just to make sure they're right. It's going to be negative infinity, 0, and 0. Okay. Want me to go over section 8.3, the homework for 8.3, please send me an email. I hope that this was enough. I hope it was helpful for you. And if you have any other questions, you can always send me an email too. I'm hoping to get this video to you by the end of the day on Tuesday. That way you have Wednesday to watch through it and think of any questions that you need to ask me. But I wish you guys the best of luck on your exams. And I wish you the best of luck in the rest of your college career. Happy holidays.